We want to sketch this function in this domain, showing any stationary points. We want to find the greatest and least values of the function over the stated domain. And I'm going to assume that we're only allowed a scientific calculator, so we can't just graph it. So let's look for endpoints to start with. So f of -3 is going to be -3 cubed plus 3 over 2 times -3 squared. Take away 6 lots of -3, add 4. So, using our scientific, we have got -3 cubed, add 3 over 2 times -3 squared, take away 6 lots of -3, add 4. That gives us 17 over 2. And let's do f of 3. So we could probably just edit this one. Let's go back and just change all of those negatives into positives. Doesn't really make any difference on the square. And that gives us 53 over 2. Now we need to look for turning points. So differentiate f dash x is 3x squared. Now if we do this one, the 2 comes down and multiplies, which cancels with the 2 on the bottom, so we'll get 3x and minus 6. So if we want f dash x to be equal to 0, that means that 3x squared plus 3x minus 6 equals 0. Divide through by 3, x squared plus x minus 2 equals 0. And we can factorize that. X and x, 2 and 1. This one needs to be a plus, this one a minus. So x is -2 and x is 1. Now, these are both inside the domain, so we're going to need to work them both out. So let's calculate f of -2, and then we'll calculate f of 1. So for -2, we can go back through and edit it again. So let's replace that with -2. Let's replace the 3 here with -2. And we'll replace the 3 over here with -2 as well. That gives us 14. And with 1 we'll probably be able to do that without the calculator. So what we'll have 1, add 3 over 2, take away 6, add 4. So 5 take away 6, that's -1, so that's going to be a half. So 53 divided by 2, so that would be 26.5 in decimal. So that's the highest point, and the lowest point is going to be the half here. So the global maximum on our domain is 53 over 2, and the global min on our domain is at a half. Now we can confirm that using the class pad. So we've got x cubed, I've already got x cubed in, which is handy, plus 3 over 2 x squared minus 6x add 4. Now we only want to plot that in the domain we're given. So we can use a given and then put in here -3 is less than or equal to x, which is less than or equal to 3. And we can graph that. So we've just got this bit here. We need to actually take the x's. Let's take them from -4 and the maximum to 4. And OK that. So here we go. And so what we can do is look for the maximum value within the domain. So analysis, gsolve, and go for the maximum, and there it is, -214. And then we could go for a local minimum, and it finds it there. And then if we look for the endpoints, we can do the ycal when x is at -3, and then we can do the same thing, do a ycal when x is 3. And then we can see that the 26.5 here, the 53 over 2, was the highest point. If we just go back to the minimum, 0.5 is the lowest point.